it. There, I found it. Okay, so with this one, this is the rest of yesterday's. This is the part 2 from yesterday. So it left off with this, and then I said, now go find the integral. And I'm presuming that we would like to see what steps to do next. Well, because of the process of partial fractions, we're allowed to break that longer quadratic that was in the denominator of the term. We're able to break it into these 2 simpler fractions. And we want that because over on this side, we're able to take this 3x minus 2 and do a u substitution with it. So here we'll say that u equals 3x minus 2. If you do a u substitution, we also need a du substitution. I'm saying du as a differential. And one thing that I picked up on from earlier today was, well, what's going on here? This really is like du dx, like it's a derivative. But if we separate the variables, put dx on the other side of the equation, it's no longer a derivative. It's an equation that uses the small, tiny amounts of change that we call differentials of the variable. So a derivative is a grouping of differentials. A derivative mean like, the change of u with respect to x. And we write du over dx, but by using kind of like a separation of variables idea, I'm not looking at a derivative, I'm looking at this differential. So it still structures like a derivative, like the derivative of 3x minus 2. But the dx has to exist. So if it was on the bottom over here, multiplying both sides by it, that is a really sloppy algebra approach, but it works. It's like a shortcut hand wave math magic reason that it works. But there it is. We're treating it like a number. So therefore, du equals 3dx. You can't forget the dx because we have it up in the integral. Now, one more step that is a technique that I've kind of got on board with recently, so I'll let you know, I'm just going to share with you. It's the fact that if we solve this to get dx by itself, dx now equals du over 3. That can go back up into the integral. I'm going to do a bunch of stuff all at once. So I'm going to put a pause right here. And I'm going to go to the other one. And I'm going to do a u substitution again. Let me change color because even though the letter is the same, it's referring to something different. So over here, my u substitution will be this denominator. By the way, those were the 2 factors we got from splitting apart or factoring the quadratic. And then du just equals dx. In fact, we don't even need the 1. It's just du is dx. So we're going to swap that, and we're going to swap this. Okay, that's all of the setup and the u substitutions. We use u substitutions because it's a letter that doesn't necessarily get permanence. It's allowed to be changeable. I use a red u because I want to show you how it's for this integral. And I use a green u to show how it's going to be for that integral. Technically, it's at the same step. Technically, yes, it's the same letter, but it doesn't have to be like ingrained, like it is locked as that letter. So I'm throwing u subs all over the place, but I hope the color really helps piece that out. Okay, let's do the substitution. So we have 3 over 14. Sorry. We have 3 over 14, that didn't change. We have the integral, and it's still 1 on the top of. But on the bottom, instead of 3x minus 2, we're going to put the u substitution that swaps it out. And then dx is du over 3. And what we do with the over 3 is we travel it all the way to the front. So I guess I'm going to use this symbol. We're going to travel because it's really the fraction 1/3. So that 1 over 3 being a value is going to move all the way out to right there. And then I'm just going to cross it. It's going to cancel out. So the constant has been pushed all the way out in front of the integral. Over here on the other side, so negative 114. So we still have that part. But this time what we have is u d, oops, there we go, u du. Got to check my letters, make sure they're right. So that's just a simple substitution of what we said was in this side of this integral, how we substituted that out. Okay, surveying what we have. Clear out this and do a little rewrite. These are the same integral. They're the exact same integral. So we can maybe combine them cleverly. No, we can't. I said they're exact same integral. I just made a mistake. My mistake was that's a u and that's a u. They're different expressions when we evaluate them. So remember that for the future, myself and you as well. Let's think about what cancels. What cancels are the threes. 3 on top, 3 on the bottom to cancel. Nothing over here matters, so just leave it the way that it is. A rewrite of what we have. No, we're ready just to jump into it. What's the antiderivative of 1 over u? What's the antiderivative where the thing that's our function is on the bottom of a fraction? And this came up in this morning's activity. It's the natural log of the absolute value of that expression. Equals 1 over 14 times the natural log of the absolute value of u plus minus 1 over 14. And now we focus on this expression, this integral. Once again, the antiderivative of 1 over something is natural log, absolute value of that something. Get the plus c in there because you need that part to be there. Now continue on. U, we've identified up above as, well, if I can scroll right, 3x minus 2. And then this u as x plus 4. So we're going to put them all back in. Here is our final answer. It is all right. We'll leave it with that.